Definitely we need our calculators, because you'll notice in the directions, we're not only setting them up, but we are working them out. So we're gonna come up with the answer.
Can you do the calculator that's like closest to you?
Everybody find practice test 2?
Oh, wait, check it. Plug out, plug it.
I'll come around later, get the extra papers. All right, here we go. How many different sandwiches are possible if you have 3 kinds of bread, 2 kinds of meat, and 4 kinds of cheese? Any thought on that? Exactly, Mr. I gotta make sure I turn this on. Exactly, Mr. Ayers. This is a jumper shirt problem. Only instead of picking a jumper and a shirt, we're picking a bread, we have 3 choices. We're picking a meat, we have 2 choices, and a cheese. So we're just gonna multiply together, that is exactly right. So the answer to the question is 24. How many ways can 10 chairs be arranged in a row? 10 factorial. Okay, so then we go to our calculator and we type in 10 factorial. And I do not know what that is. So 3,628,800. Remember, 10 things in a row is 10 factorial. It doesn't matter if they're chairs or people or books, it doesn't matter. 10 in a row is 10 factorial. Let's see. Now we have 5 multiple choice questions, and each question has 4 options. How many ways can we do 5 multiple choice questions if each one has 4 options?
4 to the 5. Just 4 to the 5th.
4 to the 5th, good. I'm gonna talk about yours in a minute, Levi, but let's look at this quiz. Here's the quiz, 5 questions. 5 questions. How many choices do I have for the first question? 4. How many for this one? You see why it's 4 times 4 times 4 times 4? Now let's talk about what you said, Levi, because people have made this mistake. That's 1,024. So the answer to the question is 1,024. Now, Levi said this. It's not right, that's fine, it's not right, but we have a bigger issue. This literally says, I have 4 things, and I'm gonna choose 5 of them. Does that make sense? This is why some of you were couldn't get your calculator to work. It was telling you error, because you can't have the little number first. Could we do 5C4? It's still the wrong answer to this problem, but does this make sense? 5 things, taking 4 at a time. I can do that. I cannot do this. So when you set up your C's and P's, you have to have the big number first. This is how many I have to pick from, and then I'm gonna pick some from that, okay? This is not the answer to this problem. The answer to this problem is simply 4 times 4 times 4 times 4. How many ways can I give away 4 identical blue markers in a class of 12? So I have 12 of you, and 4 of you are going to get a marker. All right, so here's my pile of 12. I'm going to reach in and give you a marker. 4 of you are going to get a marker. twelve C4. That's exactly right. Now, let's talk about that. Why is it a C trade, do you know? The order doesn't matter because the prizes are all the same. If the prizes are different, then it's a P. If the jobs are different, if you are picking for different things, different prizes, different jobs, different whatever, it's a P. But if the prizes are all the same, it's a C. Anybody know what 12C4 is? What?
495.
495. Remember, on test day, which is Monday, we must write down the answer. Okay, this is good, have the setup there, but this is the answer. All right. Toothpaste. How many ways can I arrange those letters? Who remembers how to do this? How many ways can I arrange those letters?
How many letters there are in it?
Count how many letters there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So 10 fact.
Start with 10 factorial. He's right. However many letters you have, you start with that. All right, have I got everybody that's here? Okay. Am I done? Is the answer 10 factorial? No. What else do I have to do?
Divide by 3 factorial.
Why am I dividing by 3 factorial?
You have 3 teeth.
3 t's. So I'm dividing by 3 factorial. Those are my t's. 2 factorial because of my o's. Is that it? Now, I want everybody to type this in because these are the ones that if we aren't careful, we end up with the wrong answer. The right answer, the answer you should come up with is 302,400. If that's what you got, right on. If that is not what you got, make sure that you are typing in 10 factorial divided by 3 factorial divided by 2 factorial. These are individual divisions. You are dividing by both of those things. Number 6. How many ways can 5 people be seated around the dining room table? It's 4 factorial. Why is it 4 factorial? Because we're in a circle. Circles have no beginning and no end, so there are fewer arrangements.
How do you know the table's a circle though?
Well, it says around. So it wouldn't, if the table were rectangular, it would still be the same. It doesn't matter. We're not in a line. We're not in a line. So if we're in a line,
So right.
anything that's not a line,
Okay.
okay? So if we're not in a line, it's 1 less factorial. Okay, so 5 people on a log, sitting on a log in the woods, would be 5 factorial. But 5 people around a campfire would be 4 factorial. And 4 factorial is 24. So the answer is 24. All right, I've got 8 seniors and 6 juniors. And I am gonna pick 2 seniors and 3 juniors to be on my team. Any ideas about that? Well, let's pick the seniors first. Okay, let's do the seniors. How many seniors do I have?
8.
How many do I want?
2.
Okay, you're gonna be on my team. 8, choose 2. Is that gonna be P or C? C. AC2.
When would it be P again?
If I were picking a president and a vice president.
We're doing
If I'm picking them for different things, or a captain and a co-captain, that would be a P. But I'm just picking them to be on my team. Order doesn't matter. Okay, what is 8? C2. 28. Okay, so I got my seniors picked. There's 28 ways I can pick my seniors. Now I gotta pick my juniors. That would be 6C3. Isn't it exactly the same thing, just different numbers? Okay, 6 juniors, pick 3. All right, what's 8C3? 20. Now, remember, I'm picking seniors and I'm picking juniors. What do I do when I'm doing this and this?
Multiply. Multiply.
Multiply. Kids, we talked about this. I don't know. You just gotta know that and means multiply. What means add? Or. If I were picking boys or girls or juniors or seniors, I would add. But I'm not. I'm picking both. I'm picking seniors and juniors. So those options get multiplied. It's like a jumper and a shirt. It gets multiplied. So the answer is 560. All right, number 8 is a probability question. So I know that a probability question is going to be a fraction. At least that's the way I'm going to build it. I'm going to build it as a fraction. So what am I doing? I am picking, this time it is a 4-card hand. So my denominator is 52C4. Remember, when you do probability, the denominator is always the total. How many cards total in the deck? 52. How many total am I choosing? 4. 52C4, that's my denominator. Now the numerator is what I want. So I want all red.
26.
There's 26 reds, and I want 4 of them. These do not reduce, okay? Do not try to reduce this, you can't. The only thing you can do is type it in. I got 0.055, it says round to 1,000, so I'm saying 0.055, what do you think? Does that look right to you? So there's about a 5% chance, 5.5% chance, that if I just threw out 4 cards to you, they would all be red. Okay? Number 9. What is the probability of a 4-card hand? All right, same denominator. If you're doing a 4, all right. You know, we got a long road ahead of us. We gotta stay awake, man. 52C4 is my denominator. Anytime I'm doing a 4-card hand. Numerator, exactly 2 queens. What's that one look like? Exactly 2 queens. 4C2. Why is it 4C2, guys?
4
There's
queens.
4 queens, and I am choosing 2 of them, right? But this problem is tricky, because we're not done. You guys see why we're not done? How many cards do I have in my hand right now?
4.
No, how many do I have in my hand right now?
0.
Well, literally 0, but I have picked 2 queens. I have 2 queens in my hand, I picked them. There were 4 queens right here on the table, and I picked 2 of them, I got 2 of them in my hand. How many cards am I supposed to have in my hand?
4.
Okay, wait, I only have 2, so that means I need 2 more cards? What kind of cards do I need?
Doesn't matter.
Well, it sorta does matter. They can't be
Queens.
queens.
48 C2.
48C2.
Mmm.
48C2. Because in this hand, I have to have 2 queens and 2 cards that aren't queens.
So, oh, I see. Yes.
Gotta have 4 cards. If 2 of them are queens, and you have to have exactly 2 queens, then the other 2 can't be queens, and they come out of 48. And they're multiplied together. That's a multiplication. Because I need 2 queens and 2 other cards. All right, so let's type that one in. Wow, that's a lot bigger. Did I type that in wrong? I got .025 basically. That doesn't seem right.
That's what I know.
That's what
Wow, that means there's a 2.5% chance that I would get 2 queens. Interesting. No, it's 2.5, isn't it?
I pulled 2 aces.
All right, number 10. Read question number 10 and tell me
What's your 54?
what your strategy is going to be.
Did you have to shoot
Tree diagram. Kids, here's the thing. No one's going to be standing up here coaching you on test day. You have to be able to read the problem and just kind of feel like, okay, what's happening here? I'm having popcorn and soda, and one depends on the other. That is a tree diagram situation. Your 2 things are soda and popcorn. Now, I gotta get them in the right order on my tree. So does anybody remember what I told you? What goes on the bottom of the tree? The question. Always the question goes on the bottom. So the question is, find the probability that they'll serve soda. Read it carefully. Find the probability they'll serve soda. So soda goes on the bottom, which means popcorn goes on the top. And then soda and more soda. Number 1, everybody understand this is a tree diagram problem. Everybody can see that when you read it. Number 2, everybody get why I have it arranged that way. If you arrange it differently, you'll get the wrong answer. Okay, that's why we're arranged this way. Okay, now I like to do, I think it's easier to do this one first. Doesn't really matter. What is the probability that I have popcorn?
50.
Okay.
Can you be asked? Can I ask how you find that? It's 100%.
We serve popcorn twice each week.
Oh.
So 2 days out of 5, the school cafeteria has popcorn. So the probability we have popcorn is 2/5 or 40%. Read the last question, read it. You see where it says we have popcorn 2 days out of 5? So that means we have popcorn 40% of the time, and we don't have popcorn 60% of the time. If we have popcorn, there's a 90% chance we have soda, which means there's a 10% chance we don't. If we don't have popcorn, there's a 45% chance we serve soda, which means there's a 55% chance we don't. We okay with those numbers? Okay, so now what's the question? What's the probability I'll serve soda? Well, I can serve soda on popcorn days. So popcorn and soda, those get multiplied. I'm having popcorn and I'm having soda. Or I can have soda when I don't have popcorn. So no popcorn and soda. Is that? Everybody okay? Popcorn and soda? No popcorn and soda. So let's see. This one's 0.36. And that one is 0.27. So popcorn and soda multiplying. No popcorn and soda multiplying. And then, since it's either popcorn and soda or no popcorn and soda, what do I do with these two numbers? Add them together. And what is that, 0.63? Is that all right with everybody? All right, let's read question 11. What's your strategy here on question 11? Well, we either have a strategy or we leave it blank and miss it. We don't want to leave it blank and miss it. Venn diagram, absolutely it's a Venn diagram. What's going on that tells me it's a Venn diagram? I got 60 kids, 40 of them are teaching, 35 of them are nursing. Some of them might be doing both. Read question 10, read question 11, don't they sound different? So what's this Venn diagram gonna look like? Yeah. So we've got teaching and nursing. We have 60 kids on the bus. 40 of them teach. Don't you dare put 40 here. That's not 40. 40 is the entire circle. 35 of them like nursing. Every student on the bus likes at least one of the careers. So everybody's in the circles, nobody's out here. Does that make sense to you? Every kid on the bus does one or the other or both. Anything about that bother you at all?
95.
How many people are there right here? 75. So wait a second. 40 voted for nursing, 35 voted for, or whatever it is, 40 for teaching, 35 for nursing. So 75 votes were cast, but there's only 60 people? What does that mean? 15 of them voted for both? 15 too many hands went up, so they went up twice. Now, if the whole teaching ball is 40, but 15 of them are in the overlap, then this has gotta be 25. And if the whole nursing ball is 35, doesn't this need to be 20? And now I can answer the question. How many indicated an interest in only nursing? Only nursing would be 20. Does that make sense to you? Everybody, does that make sense? Perfect. All right. Switching gears, now we're going to expand this. Who remembers the steps to expanding this? So we'll build our Pascal's triangle,
Yeah.
right?
Yeah.
So let's recall how we build that. We build that by starting with 1 and 1. Each row starts with a 1 and ends with a 1, and then in between numbers are found by adding the two above. So it pyramids out. So 1 and 1, and then 3, 3 in the middle. 1 and 1, 4, 6, and 4. That's how we build it. And I only built that much of it because notice this is to the fourth power. So I need the 4th row. So I'm gonna write those numbers down. 1, 4, 6, 4, 1. All right, anybody remember what comes next? Put in my X's and Y's. Put in the pieces of the problem. And the pieces of the problem are 2x. And 3y. Okay? Now we need our exponents. Can somebody besides Gabby, I love you, let's give someone else a chance here if they can. Is there anybody else that knows how to put the exponents on? Levi?
Now you go from like 4, 3, 2, 1, 0.
On the x, the first one, I start with 4. And then I just count down.
And opposite.
And then opposite the other direction. And a little thing we notice as we're doing it, just to make sure, we got a lot to keep track of. In each term here, the exponents should be adding up to that. Okay? Now, these are individual terms. And all that's left to do is simplify. Okay? Now, when you simplify, remember, anything to the 0 is 1. So you can just forget about it. Okay? If it's to the 0, you don't need to worry about it. But when you're raising one of these to a power, the number gets raised to the power 2. I hope you put parentheses, you should have, around everything. So what is 2x to the 4th?
16.
16x to the 4th. That's your first term. Now your second term is going to be a little more work, because your second term is your 4, and then what? What's this?
8x cubed.
8x cubed, and then 3y. So you're actually multiplying 4 times 8 times 3. All that's multiplying. So 4 times 8 times 3, what is that? 96? And you still have your x cubed and your y, so don't forget about that. Now, the next term, and here we go, same thing, be careful, you have your 6, what's this? 4x squared, what's this?
9x or 9.
9y squared. So now we have 24 times 9. 216, x squared, y squared. Got it? Right, you do the next one. Simplify this. You are multiplying 4 times 2x times 27y cubed. Did you get 216 again?
Yep.
And that's okay, that can happen, that's no big deal. You get whatever you get. And then on the end, to the 0 is gone. Anything to the 0 is 1, so multiplying by 1 doesn't change anything, you just disregard it. And what's that last term gonna be? 81, y to the 4th. Okay? Now, question 13 is the same, except luckily, we only want the 5th term. So we don't need, this one, we had to expand the whole thing. So do you understand that this is like the first term, and the second term, and the third term, and so on? Well, I want to multiply all this out all the way, but I don't want to simplify and do all that. I just want to know what is the number, or the term, that's in the 5th spot. Okay? So think about how you built all these. What did we start with? What was the very first thing we did when we built this? We wrote down the numbers in Pascal's triangle, right? And we were lucky in that problem because it was only to the 4th power. This one is to the 8th power. So you have a choice to make. Could you, and I'm not going to because I'm clearly out of room, but could you keep building the triangle all the way down to the 8th row? Absolutely you could. And when you got it all the way down to the 8th row, you would count over first term, second term, third, 4th, 5th, and that's the number you would take, because you are only interested in the 5th one. All right? I'm not going to do that because I remember a little shortcut that I shared with you the other day. Does anybody remember it? You don't have to use it. You can always build Pascal's triangle.
Is it
Yeah,
Yes, exactly. The numbers in Pascal's triangle are the combination numbers, the C numbers, for that number. So in Pascal's triangle, the 8th row will be 8C8, 8C7, 8C6, 8C5, 8C4, 8C3, 8C2, 8C1, 8C0. Those are the numbers in the 8th row. Now, it would take me a long time to type all those in. Luckily, I don't need to type them all in, because what am I interested in? The 5th one. So 1, 2, 3, 4, 5. That's the one I want. For this problem, that's the only one I want. So what's 8C4?
70.
What?
70.
70. So my number is 70. Remember, we start by writing down the numbers. I only need one number. I need the number in the 5th spot, and that number is 70. And I got that by simply 1, 2, 3, 4, 5, counting. No magic, no tricks, no formulas, I just counted. Next to that will be an X and a negative 2Y. Up here I had 2X and 3Y. Here I have X and negative 2Y. Is everybody okay with that? What's the last thing I need? Exponents. Now, we know that on the first, whatever the first thing is, in the first term, that exponent's that number, right? So on my X, right here, this is the first term. On my X, this would be X to the 8th. 7th, 6, 5, 4, won't this be X to the 4th? And if it's X to the 4th, then this guy's also gonna be a 4, because they gotta add up to 8. And again, there's no trickiness here. You are simply counting down, just like you do when you build this one. All right, now we simplify. So we have 70, X to the 4th. All right, now what's this guy? That's not a minus, that's a negative. Negative 2 to the 4th is 16. So I'm going to take 70 times 16. So the answer to that question is 1120 X to the 4th, Y to the 4th. That is the term in the 5th spot. Okay. Now we're going to calculate 9P5 by hand. So you will have a calculator, your calculator, for this entire test. I know you can type in 9P5, and I don't care if you do. You type it in, you'll know what the answer is. We're supposed to be kidding. I don't use P very often. So I better be getting 15,120. But if that's all you write down, you don't get any credit, because you're supposed to do this by hand. That's my answer. I hope I end up with that. But I have to do it by hand. So I have a formula. Does anybody remember the formula for the P's?
Is it 9 over 5?
It starts with 9 factorial over just 4. Just 4. The C's would be over 4 and 5, right? Have 4 and 5 both. But P's, it's just the difference. Okay? Now, my rule is you can't go to the calculator until you have canceled out your denominator. your denominator will always cancel. So 9 factorial means 9 times 8, times 7 times 6, times 5, times 4 times 3 times 2 times 1, right? That's what 9 factorial means. And 4 factorial means 4, 3, 2, 1. So what's gonna happen? Everything from the 4s on are gone, and now you can use your calculator to type 9 times 8 times 7 times 6 times 5, and guess what happens? You get the answer. Okay, so on this problem, guys, listen to me. If I don't see this and this, you don't get credit. So make sure you know your formula and you know how to break it down and cancel it out. Okay. Now we have another Venn diagram. And we know that the probability of liking apples is 0.65. The probability of liking bananas is 0.8. And who remembers what that symbol right there means? And. So this means the probability that you like apples and bananas is 0.55. Now, can I put 0.65 right here? It says the probability of apples is 0.65. Can I put that right there? No way. Because why? 0.65 is the whole circle. I can't put that in there. What can I put in? Right there? Because where are apples and bananas? Aren't they right there? So I can put that in. If the whole apple ball is 0.65, then this right here has to be 0.10, 0.1. If the whole banana ball is 0.8, then this part right here has to be 0.25. So the question says, what's the probability? I don't like apples, no apples, but I do like bananas. Doesn't that mean bananas only? And where are the bananas only people? 0.25. I don't want apples and I don't want bananas, so I do not like either. So in other words, I'm not in here. Where am I? I'm out here. Well, wait, how many people are out here? 0.10. How do we know that? Because 10% and 55% and 25%, oh wait, did I add wrong? That adds up to 90%. And how many people are there in the population? 100%, right? So 90% are in the circles, 10% are out of the circles. All right, one more page, and the test is over. Don't get excited, the period's not over. The period's not close to being over.
Oh, Mrs. Moore.
I know, isn't that awesome?
No.
All right, here we go. Last time you saw a problem like this with a chart, it involved M&Ms and blue ones, green ones, yellow ones. This involves two classes of students. In class 1, 60%, 0.6, love math, 20% love English. So it's your percentages, it's just with classes instead of colors, okay? So, A, what is the probability of not science and not science. So in other words, we are picking one kid from each box, each class. What's the probability that class 1 does not like science? 0.9. If there's a 10% chance I do like science, then there's a 90% chance I don't, right? How about class 2? 0.8. It's not science and not science, so those are getting multiplied, and the answer is 0.72. Right? What is the probability that the first one likes English and the second likes math? Alright, so first English is 0.2. Second math is 0.4. With me? Gotta be this and that, so I'm gonna multiply, so that's 0.08. Probability both will like English. So English and English. What's that gonna look like? 0.2 times 0.3, 0.06? Even being bored out of your minds, this is easy, right? This is easy. Last one. One likes math, and the other one likes art. Math and art. Is it 0.06? That's not the answer to that one. Why not? Yeah, we don't know who's who. It doesn't say first kid likes math, second kid likes art. It's, I just have one of each. So it's math and art, or it's art and math. Do you see the difference between problem B and problem D? B and D are different. So art and math would be 0.04. So now I've got two answers. What do I do with those? Add them. So the answer is 0.10. Do you see the difference between problem B and problem D?
Where did you just do the last problem at?
What?
Where did you just write all the stuff for the last one?
Right here.
Oh.
All right, that's practice test 2. Now, I got a little in-class review for you to work with a partner on. So you will get in a group of 2 or 3, no more than 3, and no solos. So everybody's with somebody.
Thank you.
Ooh. And that means some of you have to move.
You have a calculator?
So Ronnie, I'm your partner. There's Gabby over there, she would be a good partner. We already did. And she's already voted someone, she got it. Let's find somebody. You together? Blevins, we are working.
I am working.
All right. It kind of doesn't cut the mustard. We gotta be working.